In this video, we're going to create a simple Node.js application in Google Cloud Shell and deploy the application to a virtual machine in Google Compute Engine. So we are going to start by entering the Google Cloud Shell. We're starting here from the Google Cloud Platform console page, dashboard page, and there's an icon up at the top right for activating the Cloud Shell. And that brings us to a terminal, and I'm just going to put that in its own tab. And the major benefit of the Cloud Shell environment is that it has a lot of development tools already installed. And so we're going to use the Express Generator app to generate our Node application. So the command for that is npx express generator --view EJS. So we're going to use the embedded JavaScript view engine, and we're going to call the application myapp. So that goes ahead and generates the application for us. We are going to move into the myapp directory. We will install the dependencies, so npm install. And then we're going to run the application. Now, for this to work in the Cloud Shell environment, we are going to set a couple of environment variables. We're going to set the port environment variable to 8080. That's just going to make it really easy to preview the running application. And we're going to use the debug environment variable, so we will see the requests as they come in on the console. So port equals 8080. Debug equals myapp:*, and then the usual npm start command. So that starts the application running. We get the debug message that the application is running and listening on port 8080. And then in the Cloud Shell environment, there is the web preview feature, which we can use to preview that running application. So if you click on that icon, there's a shortcut to preview the application that is running on port 8080. You could preview applications running on other ports if you wanted. So we're going to preview the application running on port 8080. And the Cloud Shell environment has a custom domain for each user, and that basically forwards to our application running on port 8080. So there's our standard Express skeleton app. Now we'll go back to the terminal window, and I'm going to stop the application. And we can make changes to the source code of the application. So the Cloud Shell environment includes an editor, so we'll just open that up. And this is kind of your traditional IDE, list of files on the left-hand side and an editor on the right-hand side. So we're going to modify the index view. So views index.ejs. Actually, no. Let's modify the index root. So roots index.js. And we're just going to change the title from Express to Express 1, 2, 3. So something that we can see. And we'll restart the application. So it's running again. And I'm going to go to the Preview tab, refresh the application, and then we see the updated application. Okay, so let's stop the application once more. Now, if I go and refresh the application one more time, obviously it can't connect anymore because I stopped the application. One of the limitations of this domain name is that it's only accessible to the logged in users, so to the developer that's logged into Google Cloud Shell. This is not a publicly accessible domain name that you could use to host your app at. So the next thing we're going to do is deploy this application on a virtual machine running in the Google Compute Engine environment. And in order to do that, we're first going to set up a firewall rule to let the traffic through on port 8080. So I'm going to go back to the dashboard, and we are going to go to the networking group and into the VPC network section and the firewall page. So this page lists all the firewall rules that apply to this project. There's a number of default rules already configured. So for an HTTP server on port 80, a secure web server on port 443. So what we want to do is add in a new rule that's going to allow traffic through on port 8080. So we're going to click on the Create Firewall button. And we're going to give this rule a name. I'm going to call it Allow HTTP 8080. Self-explanatory, doesn't really need a description. We're not going to log the traffic that's affected by this rule on the default network. Standard priority. This is an ingress rule, so it's going to affect incoming traffic to our network. And when we get traffic that matches this rule, we are going to allow that traffic in. So the action is to allow. And the specified target tags, these are tags. We're going to create a tag that we can apply to a virtual machine instance that will open up the port on that instance. And so I'm going to call this tag HTTP server 8080 to distinguish it from the stock HTTP server tag that already exists. And then we have to identify the source of the traffic that we're going to admit, and we're going to just allow traffic from anywhere. So if we want to specify that we're going to allow any source traffic, we can use the address 0.0.0/0, which will match any source IP address. We don't need a second source filter. The last thing we need to specify are the protocols and ports. So this is going to be a TCP port, and we are interested in TCP port 8080. And then we'll click on the Create button to create the firewall rule. And in a few moments, that rule will appear in the list, and it'll be available for us to use. There it is. So unfortunately, the title's kind of clipped there, but you can see the target is HTTP server 8080, allowing traffic on TCP port 8080. Okay, so that's the firewall rule. The next thing we are going to do is create a virtual machine. So we will go to the compute group and compute engine and VM instances, and we're going to create a new instance. We will call it Lab 1. For the region, you can choose whatever region you want, but it would make the most sense to choose the region closest to you. So I'm going to choose US West 1. It selects a zone within that region. You can just go with the default or change to another zone if you would like. And it selects a default machine type. This is a bit more than we really need for this test. So I am going to change to the first generation series, and I'm just going to choose the smallest instance type available. That's this F1 micro instance type, 1 core and 614 megabytes of memory. The instance will boot from the standard Debian 10 image. And the only other thing we have to change here is, so there are some checkboxes for those standard ports. We're going to have to allow traffic on port 8080. So I'm going to expand this section here below and go to the networking tab. And I'm going to use that tag I created previously. So that was HTTP server 8080. And that is what is going to allow traffic through on port 8080 into this instance. Host name is fine, default network, everything else is fine. So we can click on the Create button. And in a few moments, we will have a running instance. So we'll just let that operation complete. There we go. And so the instance has been created. It has its own internal IP address, the external IP address, which the public can use to access the applications running on this instance. There's a button there for creating an SSH login shell on that instance, but we're going to connect directly from our Cloud Shell environment because we're going to want to copy over our application to that instance. So I am going to return to the Cloud Shell tab, and I'm just going to hide the editor for the moment. And in the shell, we can use the Google Cloud SDK to access many resources in the Google Cloud platform. So for instances, I can get a list of all the virtual machines that are running. So the command for that is gcloud compute instances list. And we'll authorize that, and we should see a list of all the running instances associated with this project. And there it is. So there's only that one instance that we just created. So now we are going to log into that virtual machine and set it up so that it'll be able to run our application. So we're going to use another gcloud command, so gcloud compute SSH to log into that instance. And that command looks like this. So gcloud compute SSH. We identify the instance by the name when we created it, so the Lab1 instance, and we also indicate what zone it's running in. So you can see that from the list there. So this one is running in US West 1B. And I got logged right into the virtual machine there. In your case, the first time you use the gcloud compute SSH command, it's going to ask you to create an SSH key and just go with all the defaults. It's going to ask for a passphrase. You can leave it blank. There's nothing wrong with that. Okay. So now we are logged in to that virtual machine. We need to install the packages that are going to be required to run the application. So the first thing I'm going to do is update the package lists on this instance. So for Debian, that's sudo apt update. And so it's going to get up-to-date lists of packages available for this distribution. And it mentions that some packages can be upgraded. So normally what you would do is sudo apt upgrade. So I would recommend going through that step. I'm not going to do it here, however, because I think that's going to take quite a bit of time to complete. But I would encourage you to do that for your own application. So I'm going to bypass that for now. The other thing we need to do is we need to install Node.js to run this application. So the stock Debian image doesn't include very many development tools or runtimes, so we're going to have to manually install that in this case. We are going to get the latest LTS version of Node, so we have to add another package list to get that from. So this is the command for that. So node source has a number of package lists that will allow us to get the most up-to-date version of Node. So we have to install the package list first, and then we can go ahead and install the application. So sudo apt install Node.js. And it gives a list of packages and dependencies. We can go ahead and say yes to that. And there we go. So now if I type in node-v, so version 14 of Node, npm-v, version 6 of npm. So we have an up-to-date installation of Node on this virtual machine. Okay, so we've got all the software we need. We're going to log out of the virtual machine. So I'm just going to hit Control D on my keyboard. We're back in the Google Cloud Shell environment. The first thing I'm going to do, so we're in the app directory, I'm going to get rid of the node modules directory, so there's no need to copy all that over to the virtual machine since we'll do an npm install over there. So we'll get rid of the oops, I guess that should have been an rm-r. So we'll get rid of that directory. We will back up to the parent directory. And so now we're going to use the scp command, secure copy command, to copy the application over to the virtual machine. And so the command for that is as follows. So there it is there. Gcloud compute secure copy, the recurse flag because we want to descend into the directory and copy all the subdirectories and files. The source directory, which is my app, the destination, which is the lab1 instance, and again we should identify the zone, so US West 1B. And then so that copies all the files over to the virtual machine. So we will log back into the virtual machine using the SSH command. If I do an ls, you can see the application directory is there. We'll go into that, cd my app, install the dependencies, so npm install. And now we can go ahead and run the application in pretty much the same manner that we did in the Cloud Shell environment. And so it's listening on port 8080. We've got the debug messaging enabled, and so we can see that that the application is running. So now if we want to view the application, in this case I'm going to go back to the VM instance list. So the virtual machine has an external IP address that anybody can use. So I will copy that to my clipboard. I will open up a new tab, paste that in, and also add :8080 because that is that's the port that our application is listening on. And there it is. The difference in this case is that this IP address, it's a public IP address. Anybody could connect to the application. In contrast to the Cloud Shell domain name, that would only be accessible to the logged in developer. So there we are. We've deployed the application on a public facing IP address. Okay. So let us stop the application. Oh, and you can see the logging there. So if I refresh the page, you would see, because the debug environment variable set, we see every request logged on the console. Okay, so let's stop the application. Control C. I'm going to log out of the virtual machine. Control D. And I'm going to make some changes to the application to just demonstrate a few more features. What I want to do is add a route to this application that when followed will cause the application to exit, or the server to exit. So in our index page, or sorry, in our index view, let's open that up. I'm just going to add in a couple of links, one to go to the home page and one to follow the crash path. So there we are there. So two links, one to the home page, one to the crash path. I'm going to add a route for the crash path. So in the routes folder, I'm going to make a new file. I'm going to call it crash.js. And I'm going to put the code for a router in there. And so this is just kind of the standard format for a router in Express. So we require the Express module. We make a router object, and we use the get method to cause the router to be triggered on a get HTTP get request. We give a path. So this is not for the route, the root path of the application. It's actually specified in the app.js file, which we'll see in a moment, but no subdirectory after that. So when this route is triggered, we'll call this callback function, and it's going to render the index page with a different title. And then the second thing that's going to happen is, let me just close the terminal for a minute here. The second thing that's going to happen is we're going to set a timeout to call this crash function after 4,000 milliseconds or 4 seconds. So we'll send back the rendered page, and then 4 seconds later, what we are going to do is cause the server to exit. And in the app.js file, we're going to need to incorporate the new root. So we'll add in the router. And so that is the crash. So we'll call that the crash router. And we also need to link a path to that router as well. So app use crash, and then the crash router. Okay. And so now I can restart the application. I'm going to go back into the application directory and restart it. There we go. Oh, I need to install the modules or the dependencies. Install. And okay, so that's got it. And now I'll run the application. There we go. So now it's running, listening on port 8080. I'll go back to the web preview tab and we'll refresh that. So there's the new application. I'm going to follow the crash link. So we get to the crash root. And if I go back to the terminal window, what you'll notice is you see all the messages for the requests that were made, and then the server exited. We're back at the command prompt, and that is a result of this call to process exit. So that caused the Node.js server to exit. So if I go back to the web preview URL, now if I click on home, it's not going to be able to connect, or even if I click on crash, it's not going to be able to connect because the server is not running. Okay, and so what we're going to do with this is we are going to, let me close these up. We're going to redeploy this application to the virtual machine. So I am going to remove the node modules folder. I'm going to go back to the parent directory. I'm going to use the copy command. There it is. So copy all the updated code back to the virtual machine. We will log back in to that virtual machine. And we're going to go to the application directory and rerun the application. So now we're rerunning the updated application on the virtual machine. If I go back to that tab that has the external IP address in it and refresh it, we see the new application. And again, if I click on the crash link, we get to the crash root, and if we go back to the terminal, you see that that the application has ended. The reason I added in this crash route was to show the benefit of using a process manager to keep a Node.js application alive. So instead of running the application directly, we are going to run it under the control of a node or of a process manager. We're going to use the PM2 process manager. So we will install that application directly. So the command for that is sudo npm install pm2 at latest-g. So we will install it globally. And what I am going to do is I'm going to go to the bin directory of this application, and yeah, so the bin directory of the generated application contains the www script. This is the node application that starts our entire application. And normally we could run this directly, like node www, but what we're going to do instead is run it under the control of the PM2 process manager. So I'm just going to there's how we previously ran the application. So we're going to use the same environment variables for port and debug, but instead what we are going to do is, instead of doing an npm start, we're going to do a PM2. So that is the PM2 process manager, and we are going to start www. So we will run that application. And what we get is some indication that that application has been added, and it is under the control of the PM2 process manager. And so we get some information about it there. It has a name. We count the uptime, whether it's online or not, how much CPU it's using, how much memory it's using, and so on. And so at this point we can, again, let's go back to our tab with the external IP address in it, go to the home page, and everything is hunky-dory. Let's go back to the terminal. The process manager can manage the logs for the application as well. So I'm going to type in PM2 logs. Okay, so that shows us the log messages for the application pretty much as we saw them before. So there are the two gets when I refreshed that page. The thing I really want to show, though, is what happens when we follow the crash link. So as I mentioned before, we follow the crash link. We see the crash page. The server exits, but the difference in this case is if we return to the terminal window, what you will notice is so we followed the crash route, and eventually the application terminated. So you can see that the app exited. But then what you noticed right after that is that the application was restarted, and that is the function of this PM2 process manager. So it monitors your application, and if it crashes or exits, then it restarts the application again. So the application is always available, even in the face of an accidental crash or error. And I can type in Control-C here, and I can even log out of the virtual machine entirely. But if I go back to that tab with the external IP address, I'll click on the home link, and everything is running correctly. And again, I can click on Crash, 1, 2, 3, 4. The program exits, the process manager restarts it, and I can click on the home link, and the application is still running. So that is the benefit of using a process manager. Okay, and that I think is everything I wanted to show in this demonstration.